Hi, Yanai. Today's lesson's on volume scale factors. So we're building on what we learnt yesterday. It is going to be quite similar, but we're adding to our knowledge of scale factors by including volumes as well. So the starter task is on the screen. We're looking at these pairs of shapes that are now in 3D. I've given you the lengths, and you want to work out the length scale factor and the volume scale factor, and then we're going to look for a link between those two numbers. So I will help you out with the cube, and then I want you to do the other two. Remember, for prisms, we want the volume. You can do that by doing the area of the front face, and then you multiply that by the depth of the tunnel. Okay, we've done the lesson on that in previous weeks. Okay, so for the cube, for the small one, the lengths are 2 by 2 by 2. The volume of that cube is 2 times 2 times 2. That's 8. For the big cube, it's gone from 2s to 4s. So the length scale factor looks like it's doubled, so that scale factor is 2. And the volume of the big cube is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. And I put it in the wrong place. Give me 1 second. This is 64 for the big volume. Okay, so we've got the two volumes, and I want the scale factor between those volumes. 8 times what makes 64? That's 8 times 8. Okay, so there's our first pair. I'll leave you to do the cuboid and the triangular prism, and then we're going to look at these pairs of numbers, and you're going to tell me what you notice about them. Okay, so pause the video if you haven't done that yet, and I will go through it in a second. Okay, so let's carry on with the rest of the answers. Let's do the cuboid next. Starting with the small one, the small volume is 1 times 4 times 3, and that's 12. Okay, now the lengths have gone from 1, 4, and 3 to 3, 12, and 9. You'll notice that the length scale factor then is 3, because they're all 3 times as big. So I'll put that at the top. Then the volume, the big volume, is going to be 3 times 12 times 9. And if you work that out, I'm not going to do that off the top of my head in the video, so I'm going to do it on my calculator. That's 324. And I've done it again. Right, 1 second. That is the volume for the big one. Okay, the scale factor is what we want up here. How many times bigger has the volume got? Well, you can divide these numbers to get the scale factor. And when you divide 324 by 12, the answer you get is 27. Right, they're all in the right place now. I'll try not to do that again. Okay, the triangular prism, it's starting with the small one, 2 by 2 on the triangle. So the area of that is going to be 2 times 2 is 4. Halve it, that's 2. And then times up by 3, and the volume is 6. Okay, for the large prism, it's 3 by 3. Divide that by 2, that's 4.5. Times up by another 4.5, and you get 20.25. Okay, the volume scale factor, well, 2s have become length scale factor. 2s have become 3s, and this 3 has become 4.5. I think that's 1.5 times as big, so I'm going to put 1.5. Okay, and then if we divide these volumes, you can get the scale factor between the volumes. So I'm going to divide my 20.25 by 6, and that's 3.375. All right, so we've got these pairs of scale factors. Hopefully you've guessed already what the link is going to be, but we're going to have a look in a second. Have a look at what it is. Again, it works for the decimal numbers, but if you focus on the nice whole numbers, you might see straight away what's going on. And the answer is, if you cube the length scale factor, you get the volume scale factor. Okay, so whereas yesterday we were squaring to get from length to area, we're now cubing to get from length to volume. So 3 cubed is 27, 2 cubed is 8. And sure enough, 1.5 cubed will give you your 3.375. Okay, so very similar to yesterday. Rather than squaring, we're now cubing. And again, if I give you some shapes that are now in 3D, you should be able to tell me some missing lengths and missing volumes, and I'm going to throw in some area in there as well, just to make sure everything is all in one place. Right, so what we need to do now is we need to upgrade our template that I've given you from yesterday. So rather than just the 2-layered template, we've now got this 3rd layer that includes volumes as well. And we've also got these extra arrows that go from the bottom of the grid at the length scale factor right up to volume scale factor. That's cubing and cube rooting on the other side. Okay, so we've got to be able to go up and down these as well. And that's my dog telling us about us getting some post. Okay, let's look at these vases. We can fill it in just as we have before. So we've got both lengths, 6 and 18. I'm going to put them on the picture. We've also got a small volume of 20, and that's going to go right at the top there. And now I can start to fill things in. What am I after? And we're after the larger volume. Okay, that's what we want down here, so that's the one I'm after. And we can use the way that we get around the grid like normal. Right, 6 and 18. What's the scale factor? 6 times by, and it's 3. Okay, then to get from here, I can get up this arrow to get to the top. The volume scale factor is the cube of 3. 3 cubed is 27. Okay, it helps you to know your cube numbers to stop you having to think about it every time. And then to get to the large volume, you just go along this top row. 20 is the small volume, times by 27, and that's going to give me 540 for the large volume. Okay, these are all calculator questions. You can use your calculator to work these out. Make sure you've got your units in your answer, and the units is going to be centimetres cubed. Okay, that one's done. There are other ways of getting around this grid. Sometimes you're going to have to use the middle row, and it depends on what the question's giving to you in order to work it out. Let's do a couple more examples before you do some yourself. So let's do the ice cream. Again, we've got both of the lengths on it. Okay, the height of this one's 40 centimetres. This one, though, is 1 metre. I can't look for a scale factor yet because the units don't agree. So before you do anything, just double check and make sure that units match. I can turn a metre into 100 centimetres, and then I can compare it a lot more easier to the 40. We'll put the lengths in, shall we? 40 and 100 now. And to get from 40 to 100, the scale factor is 2.5. 2.5, we'll put in there. We've got a large volume, which is a nasty number, but I've chosen that to make this answer a nice number. So let's pop that in the top right. So we've got up here 2, 4, nope, 2, 3, 4, 3.75. All right, and this is the one we're after, the small volume. Okay, so similar to before, we've worked out this length scale factor. I can cube it to get up to the top, and 2.5 cubed gives you 15.625. Okay, this is the number we want. I've got the scale factor and the larger volume. To get the number at the beginning, you can divide. This number divided by the scale factor gets this one. And if you divide those numbers, I'll do that quickly, you get 150. Okay, nice number, like I said. And what's the units? Our volume units are centimetres cubed, so keep them the same. Okay, that second one is done. The third one I'm going to use, but it's only going to use the top 2 rows. I'm going to show you what to do if that happens. So this one's areas and volumes, okay, a bit more trickier. So looking at the Pringles tins, the area it's giving you is of the face. Okay, let's pretend that the area is of the Pringles guy, whoever his name is, Mr. Pringle. Right, small area, that's 8. Large area, that's 200. And small volume is 120. Okay, all the units are matching, so we don't have to do any conversions this time. And it's the large volume that I want, the volume of the large tin, so let's put that on there. That's the one we're after. Okay, now we've got both of these, we've got both the areas, so that gives us a scale factor. If you divide these two, 200 divided by 8, that's 25. Okay, so we can get started by putting that in. Okay, now it's quite difficult to get from the middle row to the top row, okay? Things aren't linked between these two boxes. We can only really link them to the bottom box. So although we don't really need any lengths, it would be good to work out this bottom box because then I can go all the way back up to the top again. So 25 is my area scale factor. I can go down this arrow and square root, and that's going to give me 5 for the length scale factor. And now I'm at the bottom, I can go all the way back up this one again, the cubing arrow, and that tells me the volume scale factor. And 5 cubed is 125. Okay, and then we're nearly there because we've got the small volume, we've got the volume scale factor, and we can times them together. So the big volume is 15,000. Okay, when it's volumes, these things can get quite big, so don't worry if you get big numbers, all right? It's probably right if you've done the right sum. And what's our units again? It's centimetres cubed for volume. Okay, so make sure that you've got this bottom box if you want to get between the middle and the top row. Okay, perfect. So the ones I wanted to do today, the questions that cover volume on the same document as yesterday are the ones you want me to do. I might set some as some extension and let me know if you've got any problems. All right, great. Thank you very much, Year 9. I'll see you soon.